Hey everyone, welcome to the second episode of the Coinpickings podcast. Today we are talking about Directed Acyclic Graphs, also known as DAGs. Blockchain-free cryptocurrencies are those that use alternative systems in order to function similarly to cryptocurrencies that utilize blockchain technology. Sergio Demian Lerner published a paper in 2015 outlining his concept of a cryptocurrency called DagCoin, which deployed DAG technology instead of blockchain technology. DAG stands for Directed Acyclic Graph and can serve as a viable alternative to blockchain technology as shown in cryptocurrencies such as DagCoin, ByteBall, and IOTA. In a DAG system, there are no miners and there are no blocks. Users confirm each other's transactions via a process that confirms previous transactions with each new transaction. Because there are no blocks, there is no block size issue, and therefore the block scaling debate seen in currencies such as Bitcoin does not exist. In blockchain technology, transactions are grouped into blocks, represented by squares in the following diagram. They are confirmed by miners and subsequently added to the chain. In DAG technology, each new transaction confirms at least one previous transaction. Transactions are not grouped into blocks and are represented as circles in the following diagram. The red lines represent the confirmation link between new transactions and previous transactions. To help explain DAG technology, consider the efficient teacher analogy. Creating papers can be a considerable workload for any teacher. If Bob the teacher has 5 classes or approximately 150 students, he may have to grade 150 to 300 papers or assignments per week. Rather than spend a significant amount of his free time grading these papers from scratch, Bob decides to hold a peer review session in each class once a week for students to grade each other's papers. Each new student who turns in a paper must review the paper of another student who previously turned in a paper during the same class period. Now all Bob has to do is quickly review each peer graded paper as they are turned in to ensure that students are grading fairly. The occasional error is inevitable, but Bob is on the lookout for such errors, and he will manually take care of them as they present themselves. DAG is very similar to this peer grading system. Instead of having large mining firms confirming transactions via proof of work, DAG employs the very transactions that users make in order to confirm each other's transactions. DAG is essentially a distributed peer confirming system at scale. The more new transactions on the network, the more the available transactions to confirm previous ones. DAG could solve many issues associated with blockchain technology, such as increased speed. Low speed is a common problem with blockchain systems. DAG solves this by confirming transactions on a transaction-to-transaction basis rather than a block-to-block basis. Rather than waiting for miners to process a large block of transactions, DAG allows users to process each other's transactions on a micro scale, leading to lowered transaction costs and faster transaction times. Increased reliability. Built into the DAG system is the multiple confirmation of transactions, both indirect and direct confirmations. This leads to an increased level of security and decreased likelihood of double spending when compared to transactions on a standard blockchain. Simplified mining. Mining on a typical blockchain cryptocurrency, Bitcoin for example, has led to an oligopoly issue. That is, the majority of mining power is being sent to mining pools because of the increasing difficulty of successfully mining a block. By joining a mining pool, individual miners greatly increase their chance for profitability at the cost of sharing profit with the entire pool. These mining pools have led to the majority of hash power being concentrated in just a few places and just a few pools. This leads to a centralization effect that directly violates one of the main principles of Bitcoin and cryptocurrencies. Blockchain-free solutions such as DAG aim to solve this issue. Through the key role of individual transactions coupled with the speed at which transactions are processed, DAG provides less power in a technological sense to miners. Centralization of mining. As mentioned above, centralization of mining, especially in terms of mining pools, is becoming an increasingly difficult problem to solve in the current state of blockchain technology. The implications of centralized mining can easily lead to damaging abuses of cryptocurrency ecosystems. The advancement of quantum computing. Currencies such as Bitcoin run based on cryptographic puzzles that are hard to solve with current hardware. As technology advances, how obsolete will these puzzles become? This is a long-term issue with cryptocurrencies and won't be the source of any near-term panic, but it is an issue that must be considered over the coming years. DAG transactions aren't confirmed using the same puzzle functions as Bitcoin, and thus aren't vulnerable to this issue. High transaction fees equals no micropayments. Low or no transaction fees are essential when it comes to creating an ecosystem where micropayments and transactions can be regularly sent. In the current state of Bitcoin and others, micropayments are illogical because of the high transaction fees. IOTA, for example, touts 0 transaction fees with their tangle. a necessary step, they say, towards the integration with the Internet of Things. Division of participants. In many blockchain applications, participants are divided into several different categories and roles. These roles can lead to fundamental differences in opinion and thus can result in more conflict in the network. This conflict needs to be solved and will require the use of resources to do so, whether it be time, hash power, or money. Limit of scalability. The nature of blockchain technology and the usage of block confirmation can result in both long-term and short-term scalability issues. You've probably heard quite a lot about the Bitcoin scaling debate, SegWit 2x, and Bitcoin Cash. These forks on the Bitcoin blockchain are aimed to solve the scaling issues associated with Bitcoin. If these issues are left unsolved, we'll see rising issues of transaction fees, long transaction times, clogging of the network, and even decreased security. Hardware scaling issues. This topic is related to that of the centralization of mining. The costs associated with mining hardware are on the rise and are subsequently raising the cost of entry to the mining space, leading to centralization. The less discussed costs associated with energy usage and global footprint are also issues. If the number of cryptocurrencies and usage of them continue to rise, this global footprint will increase and cause even more issues. Data volume. The nature of blockchain technology is such that nodes need to keep individual records of the blockchain and its historical transactions. Again, as usage increases, so will the issues of scalability. DAG's deployment of transaction-to-transaction confirmation could solve these issues of scalability by being much lighter and having alternative methods of ledger distribution. Current implementations of DAG technology. IOTA. IOTA deploys a mechanism they call tangle. Tangle is based on DAG technology and is at the heart of the IOTA ecosystem. IOTA's mission is to be the backbone of the Internet of Things and bring about what they call the economy of things. IOTA makes it clear that in order to create an efficient ecosystem where people will actually interact with the Internet of Things, there will need to be low or no transaction fees. On their website, IOTA says that in this new autonomous machine economy, IOTA will be the backbone. The Tangle ledger is able to settle transactions with zero fees, so devices can trade exact amounts of resources on demand, as well as store data from sensors and data loggers securely and verified on the ledger. ByteBall. ByteBall aims to create a widely adopted smart payments network that touts a plethora of use cases made possible with DAG technology. A few examples of these use cases are peer-to-peer insurance, prediction markets, peer-to-peer betting, peer-to-peer payments via text messaging, bot stores, black bytes for private transactions, and more. ByteBall claims that mass adoption requires wide distribution. That's why 98% of all bytes and black bytes are to be distributed for free. DagCoin. Created to be the most usable cryptocurrency in the universe, DagCoin aims to deliver on a fast and scalable network with almost zero transaction fees by deploying DAG technology. On their website, DagCoin states, "We love Bitcoin, we really do. But what we all need is a cryptocurrency that gets faster every time a new transaction is made. Not vice versa. Bitcoin just gets slower and slower, and this is exactly why we created DagCoin, to become one of the fastest and most easy to use cryptocurrencies in the universe." Conclusion. Is DAG the future of cryptocurrencies? Can DAG compete with blockchain technology? Do DAG and blockchain even need to compete, or are they to have totally separate and or interconnected use cases? Time can only tell what these technologies will be used for and how they will interact with each other. DAG and blockchain accomplish similar goals with different techniques. There are trade-offs to both, and there are many developers on both sides, though it's important to note that there are significantly more developers working on the blockchain. Thank you for listening to this episode of the Coinpickings podcast. Please don't forget to like this episode on YouTube and subscribe for future episodes. Also, if you have any suggestions for future episodes or would like to see a topic covered, please leave a comment below and I'll make sure to cover it. See ya.